Alright, in this video we're looking at planes and winds type problems. Alright, so it's an application of most of the things that we've done thus far. Alright, you all have the sheet, and so far hopefully you've gone through the bearings packet and you looked at the bearings to traditional degrees video. Alright, and if you did, then great. We're setting up for this. All right, so this worksheet, the first problem on the worksheet, I try to map it out step by step. Now, as you go along, you're doing the same steps as you do in the first one for the rest of them, but we're going to do those when you come back to class. All right, so we're going to look at problem number 1, and then we'll look at another example that's in our vectors packet, and that was the last problem, problem number 26. All right, ready? All right, so I have about 4 steps here to kind of help you along the way. Before you start, right above planes and winds, I need you to understand that the magnitude is the same as your speed in this case, your ground speed. All right. All right, and for our problems, it's in miles per hour. All right, so step 1 tells us to change bearings to standard degrees. So let's look at the problem. An airplane is flying on a compass heading bearing of 75 degrees at 470 miles per hour. So 470 becomes the magnitude of this airplane vector. A wind is blowing with the bearing 105 degrees at 80 miles an hour. All right, so tells us what to do in form. All right, so first thing we want to do is circle our bearing of 75 degrees. All right, and if we think about that, well, finding that bearing of 75 degrees, all right, we should be able to draw this quickly. We're going to go down from north 75 degrees clockwise. That's going to leave us with an angle of 15 degrees right here if this is 75. All right, and then that lets us know in traditional degrees that this is equal to 15. All right, so a bearing of 75 degrees is equal to 15 degrees. All right. At the same time, let's go ahead and figure out the rest of the bearings. All right. This is the wind bearing. The wind is blowing in the direction 105 degrees, or a bearing of 105 degrees. All right. And so we could do that again just to make sure. All right. We got 90 plus what looks like 15 more degrees. All right, and that would be that 105. So the wind direction is 360 minus 15. All right, and in that case, it is 345 degrees. 345 degrees. So we kind of slammed that in there. All right, we found those 2 things. All right, and now we're going to keep on going with the problem. All right, the component form of the velocity of the airplane. So I label this VP. V sub B. All right, now lets me know I'm dealing with the velocity of the plane. All right, and so the velocity of the plane is going to be equal to the magnitude, which is 470, cosine 15 degrees, comma 470, sine degrees, sine 15 degrees. All right. And then we punch in our calculator, making sure our calculator is in degrees. And you can pause it if you want to do that. It's 453.985, comma 121.645. All right, so that is your vector component, all right, for the plane. All right, we do the same thing for the wind. So we take our wind information. It says the wind is blowing at an angle of 345 degrees at 80 miles an hour. So we're going to go the vector for wind is 80 cosine 345, comma 80 sine 345. All right, and that's going to give us, as we punch that in our calculator, 77.274, comma negative 20.706. All right, so you can imagine a plane is flying in its direction and the wind is blowing. If it's not blowing right behind it, then it's probably going to change its course just slightly. All right, and so what we're doing is adding two vectors at this point, the plane and the wind, and then from there we're finding some resultant vector. So let's just take a second to look at the picture of this. I'm gonna draw this right in about here. All right, so if we can imagine this for a second, we have a plane flying at 470 miles an hour and the wind blowing at 80 miles an hour. All right, and so that wind vector, since it's the magnitude, is a lot less than the plane. And we're not trying to be exact here, but we have an angle. The plane is flying 15 degrees, and we're going to say it's a pretty long vector. All right, and then we want to make our wind vector in the direction of 345, a lot smaller. All right, so we can say the wind vector in the direction of 345 degrees, just like that. All right, and so now if we add those vectors the same way we added them on the quiz, all right, if we add these vectors, we're going to, where we started to where we ended would be the vector of the plane plus wind. So we can call this the wind vector. The plane vector. And this is the wind vector. This is why I don't do videos here. All right. And this is the plane plus wind vector. All right. So you can sketch that later. In here somewhere, you want to add the two vectors. All right. Now we sketched it. Now let's add the two vectors. So we say vector wind plus plane plus wind is going to be the vector from A, 453.985, comma 121.645, plus the wind vector 77.274, comma negative 20.706. All right, and that'll give us a resultant vector of 531.259 and 100. All right, 0.939. So don't just write what I'm writing, but make sure you can get those values in your calculator. All right, now it's positive, so it's in which quadrant, guys? All right, and that would be the first quadrant. All right, which means whatever answer we get for the direction is going to be the answer. All right, we don't have to add 360 or add 180 to it. All right, now from here it says find the actual ground speed and the direction of the plane. All right, finding the ground speed is the same as finding the magnitude. So the ground speed, the ground speed is going to be the magnitude of this. All right, and let me write that better. The plane plus wind. All right, the magnitude of that is going to be the square root of 531.259 all square plus 100.939 all square. All right, and it should be 540.763 miles per hour, since that's what we're dealing with. That's the speed. All right. From there, now we also need to find the direction in which we're flying. All right, so we say theta is going to be equal to, and we say inverse tan of our y component, which is 531.259. Oops, excuse me, that is wrong. 100.939 over 531.259. All right, and that gives us a direction of 10.758 degrees. All right, and there's that whole problem done. All right, from here, we have a picture. We got everything they asked us to have. All right, so let's look at this problem number 26. So, number 26, an airplane is flying on a compass heading bearing of 300 degrees at 400 miles per hour. A wind is blowing from the southwest at 100 miles per hour. Find the actual ground speed and direction of the plane. All right, so first things first, changing your compass heading into traditional degrees. All right, we can look at 300 and go, well, a bearing of 300, if this is 0 going clockwise, will get us 270. All right, plus 30 more degrees. All right.
Society 129 is meeting in A213.
Now, that would be the compass.
Society 129 is meeting in room A213.
The compass heading. All right, and so if we take it to traditional, all right, we take that to traditional. All right, this is a 30-degree angle right here, but that means that this right here is 150 degrees. All right, so we're going 90 degrees plus the, well, this is 30, guys. All right, then this is 60. All right, so we're going 90 plus 60, and this would be 150 degrees. All right, so we got that. All right, and then we went from the southwest. All right, and so from the southwest, all right, if it's blowing from the southwest towards this way, then it would be going to the northeast. All right, and northeast would be 45 degrees. All right, now, so we have those two things that we had to translate. All right, remember, we're going to find the vector components for the plane. All right, we're going to find the vector components for the wind. We're going to add the two vectors, planes plus winds. All right, we're going to get the ground speed. Now, ground speed, all right, is going to be the magnitude of that vector. All right, and then we're also going to find the angle, all right, the direction, and the direction is going to be inverse tan y over x. All right, and we're going to kind of try to figure out which quadrant it is, depending on, depending on our values of our vector. So here we go. All right, the vector, plane vector is 400, the speed, cosine 150, 400 sine 150. All right, the wind components are 100 cosine 45 and 100 sine 45. And since cosine 45 degrees and sine 45 degrees are the same, those values are going to end up being the same, but we'll look at those. All right, and this, where we're just going to add up. So we're kind of just, we're going to make this work out for us. All right, so 400 Make sure we're in degrees. All right, we are 400 cosine 150. All right, and that's giving us negative 346.410. All right, second enter, change it to sine. All right, that's going to give us 200. All right, the other vector, if I plug it in, is 70 point, and you need to check and make sure you get it right. 70.711, 70.711, and 70.711. All right, and if we add that, add those two vectors. All right, we get our planes and winds vector. I'm going to add 70.711. All right, that's going to give us negative 275.699. All right, and 270.711. All right, and there's your planes and winds vector. All right, push of a button. All right, now it's negative positive, which puts us in the second quadrant. Second quadrant. All right, which lets us know, well, just right away, I know this is positive, negative, but whatever value we get here, we're going to add 180 to it. 180 degrees, because it's second quadrant. All right, we have this. We need to find the ground speed, which is your magnitude. So we got parentheses negative 275.699 all square plus 270.711 all square. Square root all that. So I usually type it all in together. I know I saw some students doing it separately. So parentheses. Let me just double my parentheses. Oh, actually, I don't need to with this kind for the 84. 275.699, and the negative isn't necessary once you're doing the magnitude because it's going to be squared anyway. All right, square plus 270.711 all squared. All right, I'm gonna get it from underneath there, make sure everything's all right. Looks good. All right, hit enter. Shoot, let me do that again. 275.699 square plus 270.711 square, and the square root of that. All right, there we go. We get 386.386 miles per hour. All right, and then finding the direction, we have inverse tan of your y value, 270.711 divided by negative 275.699. Close it. Close it. Plus 180. All right, and we get 135.523 degrees. All right, 3 decimal places.